I have two boys, and they're around the same age. They're 5 and 8, and they are around the same age that is the average age for children diagnosed with DIPG.
Probably the most difficult conversation that we have to do as the neurosurgeons is to let the parent know that this tumor exists.
You know, to have this bomb dropped on them, and I know what it's like to sit with a kid in your lap. I know what it's like to sit in an emergency room. What must be going through their head? That often sort of knocks the wind out of me.
Probably one of the most poignant statements that one of the children made to me was, "I want my life to matter."
What we have to do is channel that angst into actually motivating us to actually go forward.
I don't know where to start. It's just been exciting on every front.
In the last 18 months of 2 years of the existence of this effort, I would say we have made progress that we had not made in the last 10 years.
Where we're at right now is, to me, where I thought we would have been more 5 to 10 years from where the movement started.
And I would say that even within the last year, the changes, the understanding about the biology of these tumors that we have now found has really made a huge difference.
We're really turning up the pace at which we're going to beat this thing.
This is because we are creating an environment that really promotes the interaction between different scientists.
We are partnering with all the leaders in the field in DIPG, and in Toronto, in Stanford, and in Germany.
One of the most significant things that is happening to help has been the willingness of families to allow us to get samples of tumor.
Taking that tumor and banking it, keeping it, developing cell lines, developing tumor models around it becomes extremely important to developing ways to treat tumors.
And so some of the tumors that we have sent tumors to other institutions to do analysis.
For example, Chad Carr's tumor was studied by more than 20 different researchers across the world.
We discovered that his tumor was driven by
a gene called P10.
P10 is what we call a tumor suppressor gene.
It slows the brakes on tumor growth. We could tell that it was an important part of the story of his tumor in the entire tumor, not just a small part of the tumor. And that allows us to really make a case to the field to say P10 is an important part of that. And you should consider using therapies that other fields, like the breast cancer field, are developing. And we are still gathering information, and each patient is obviously different, but we have a number of patients who we are very optimistic about how they're doing on those treatments.
So there's many facets of basic research that we believe very fundamentally will point to new therapies for the future.
It matters that we care about why tumors metabolize certain drugs, certain sugars in certain ways.
Because the amount of food consumed by cancer cells is 100-fold higher than normal cells. We can actually take advantage of this to now come up with metabolic strategies to actually inhibit these pathways to kill cancer cells.
We want to get rid of those cells. Those cells are growing where they're not supposed to grow, and they are spreading throughout the brain. And so we need to find a way to get rid of those cells.
About 5 years ago now, there are people studying ways that cells die realize that there's a new form of cell death that's called ferroptosis. Ferroptosis is an iron-dependent form of oxidative cell death in which effectively the cell oxidizes itself to the point where it explodes. Well, we're interested in killing cancer cells, we're interested in killing DIPG cells, and by triggering specific molecular components within a cell, we're able to activate the process of ferroptosis.
The way in which we are inducing cell death by inducing ferroptosis, we believe that will promote the immune responses against DIPG. I
am just excited. I am just seeing
the wheels in motion for DIPG.
I think we've turned a corner.
So we start with a baseline high-level excitement.
Like sometimes hard to sleep, we are so excited and you have so much data that you want to go back to work and design new trial and new therapies and then put those discovery into play.
And when an idea like this, when an idea about ferroptosis, when we saw the data come out of the lab and that really stuck, that's exciting. That's high-level excitement.
It's a real reasonable prediction to say that we are going
To
to,
keep this going, to keep the momentum going forward.
and that within our career, get to that cure that we're all looking for.
That's what I hope. And I know that will happen.